Now there's a second way of solving linear equations other than substitution. It's called solving by addition. Sometimes this is called elimination, but they're referring to the same thing, addition or elimination method. So the way we do this is we first start out by writing each equation as ax plus by equals c, if necessary. And by that we mean get the x and y terms together on one side and leave any constants on the other side. And then what we'll do is we'll multiply either or both equations by an appropriate number, non-zero, so that the sum of either the x or the y coefficients is 0. And by that we mean if we can add the x's or add the y's so they cancel out and go to 0, we're going to remove that variable, leaving us with just one of the two variables left to solve for. So once we do that, we'll add them together, reducing it down to one variable that we can now solve for. Once we solve for one variable, we can then substitute that into either equation to find the other remaining variable. And then lastly, we can check the solution to double check to see if it is correct. Okay, here's our first system we're going to try doing. 3x plus 2y equals 48 and 9x minus 8y equals negative 24. So the solve by addition or elimination method tells us we need to make the x coefficients or the y coefficients add to be 0. So if I was to multiply the 2 and get, say, 2 times 4 and make it into a positive 8, then the positive 8 and the negative 8 from the other equation would cancel out and the y term would go away. So that's actually what I'm going to do here. I'm going to take the first equation, equation number 1, we'll call it. And what I'll do with equation number 1 is I'll multiply through by 4. So I'm going to multiply all the numbers in equation 1 by 4. So we multiply one side by 4. We multiply the other side by 4. The second equation I'm not going to do anything to. There will be no change to it. So we're still going to have the 9x minus 8y equals negative 24. Okay, after multiplying equation 1 by 4, we're going to have 12x plus 8y equals 192 in equation 1. And then we take the second equation and we can see how the y's will now cancel themselves out after turning it into an 8y. So what we're going to do is we're going to add these equations together. Every term will add together, and we're going to get 21x, the y's will cancel out, equal to 168. And so now we're left with just x to solve for. We can divide both sides by 21. And what we'll have is x is equal to 8. And so now we have a solution for one of the two variables. Now it's just left to do is to substitute in for x and solve for y. So I'm going to substitute x equals 8, and I can use either equation 1 or equation 2. I'm just going to use equation 1. So if I substitute that number in, I'll have 3 times 8 plus 2y equals 48. So that would be 24 plus 2y equals 48. And when I subtract the 24 over, we'd have 2y equals 24. Divide by 2. We'll solve for y. Y is equal to 12. And so that should be our solution here. our solution will be 8, 12. Okay, here's another example. 4x plus 6y equals 12, and 6x plus 9y equals 12. So what we need to do now is to make the x's or the y's cancel out by multiplying through by some number. What I'm going to do here is I'm going to take the first equation. I'm going to try to get the x's to cancel out. So a 4 and a 6, let's multiply them so that one of them is a negative 12x and the other one is a positive 12x. So the first equation, I'm going to multiply that one through by negative 3 so that it would look like negative 12x minus 18y equals negative 36. The second equation, I'm going to multiply it through by 2. If I do that, it would turn to 12x plus 18y equals 24. And now we can see how when we add the two x terms, they're going to cancel out. So we'll add all the terms together. However, as a consequence of trying to make the x's cancel out, the y's are also going to cancel out. So all that's left over here is 0, and that says 0 equals to negative 12. But now we've reached a situation where these two numbers are not equal to each other, so this is actually a false statement. When that happens, then we have no solution. Now, I put this one in here since sometimes we'll look at these systems and we'll see some fractions involved with it. So first thing is first, when we see this happening, is to clear the equations of fractions. The way I'm going to do that is to multiply here both sides by 4. So the denominator of 4 can be canceled out. So everything's going to get multiplied by 4. I can cross out that 4 with the denominator. So the system would change to be x minus y equals negative 4. And so then we'd have also x plus 4y is equal to negative 9. And now we want to figure out how are we going to add the x's and the y's so they'll cancel out with each other. Well, looking at this, if I had a 4 for negative 4y, I could make it cancel with a positive 4y. So to make that happen, what I'm going to do is take the first equation and multiply that by 4. So I'll just label those equation 1 and equation 2. And multiply equation 1 by 4, we get 4x minus 4y equals negative 16. So now we have what we want. We see the two y terms will cancel when we add them together. So we'll add all these together and we'll get 5x equals negative 25. And after dividing by 5, we'll have solved for x. X is equal to negative 5. So what I'm going to do here is substitute x equals negative 5 into equation 2, even though I could use either equation here. We'll have negative 5 plus 4y equals negative 9. We'll add the 5 over. We'll get 4y equals negative 4. Divide by 4. And we'll solve for y. Y is equal to negative 1. So that'll be our solution here. Negative 5, comma, negative 1.